let's welcome our third presenter, Yalin. Right. Yalin is going to, on behalf of his team, is going to present a topic of quantifying the impacts of social infrastructure on human networks. And Yalin is a doctoral student at the University of Texas in Dallas.
You need to mute somebody. Mute everybody. Mute all. See mute all at the top there? Down a little bit. Down. There you go. All right.
Okay, hello everyone. My name is Yalin. So today my topic is quantifying the impact of social infrastructure on human network. So if we go to the literature, we could find that there is a rich study to talk about how to construct the human network based on human trajectory. For example, if we have this visiting pattern for 6 people, we could construct these human networks based on this visiting pattern, because their main assumption is people who visit a place at the same time repeatedly are likely to be social related. But in my research, we are not trying to construct the human network. We try to figure out how humans interact with different type of place and how they build relationship in a place. So in our research, our assumption is different places have different type of POI, and POI support for social events, and the social events implies social relationship. So for example, if your favorite singer want to host a concert, so which place they could choose? They may choose a stadium, they may choose a public park, but they may do not want to choose a church, because church is named for religious related work, or some of them maybe for visiting purpose. And yeah, so you could find that there is so-called appropriate bond between POI and social events. So our research is to how to measure this appropriate bond between POI and social events, how to prove it if it's exists or not. So we collect data, social events data from a website called Meetup from February 2020 to in January 2021, and in a Dallas-Fort Worth area. And the right graph, the left graph is an overview of the spatial distribution of the social events. And the right one is a labeled map. From this map, you could see a book and sci-fi and games and writing related events are mostly happened in the school area. And health and wellness and career and business related social events are surrounded by store, office, and restaurant. And for the POI data, we get it from a company called MapTube, and we reclassify 62 types into 13. And here is shown the exact number of each class of POI we have, our data set. So, so here we show the basic association pattern between POI and the events. We mark each social events as a center and build a buffer around it to say what kind of POI surround it. So each color represents a different type of POI data, and each column here represents a different type of social events. You could say the association pattern between POI and the social events are quite unique according to the type of social event. But how to measure it, how to prove it, is significant. We need to do the co-location analysis. If you go to the literature, there are two major directions to do this analysis. The first one is called a spatial statistic-based approach, which include a spatial regression model, a K-function, or gravity model. But some of it only for area data. But in our case, we have multi-classes points data, and some of them only for paired-wise relationship analysis. Because we have multi-classes points data, the combination from these multi-classes could be numerous. So this method is not good for our case. So we go to another direction. It's called a data mining approach. To be more specifically, we use association rule mining here. So association rule mining is originated from marketing analysis because an entrepreneur want to analyze the association among items based on consumers' buying behavior. They want to see if people buy one item, what's the chance they could buy another item. They try to place them together. So there is a funny fact that they found if a man buy a beer, they have more chance to buy diaper as well compared to some men do not buy the beer. So the association rule, if it looks like, is called X to Y based on two measures. The first one is called the prevalence measure. The second one is called a conditional measure. And both X and Y could be a set of items. So for our research, we want to get the association rule like this. For the left-hand side, we want to include one to multiple type of POI, and their presence are significantly contributes to the occurrence of a certain type of social events. So for the prevalence measure, we use one matrix called support. Basically, this is count for what's the percentage of transaction counting both X and Y according to the total number of data set. And for the conditional measure, we use one matrix is called confidence. Confidence is measured the conditional probability. And then we also apply that on other metrics for the interesting measure. It's called the lift value. The lift value of association rule X to Y is equal to the conditional of Y under X divided by the probability of Y. Basically, they are comparing the conditional probability with the original probability. But here is a problem. For spatial analysis, we do not have the nature. We do not have a natural transaction. We have to simulate it. But how to simulate it? So in our research, we generate random points in our research area and build a walkable scale, which is 200 meters from that random points, and count what's the POI data and the social events data inside to generate one transaction. What it means? It means if you are a person randomly stopped by a point within our research area, within your walkable distance, what's the chance? What's the probability you could observe the POI, the certain type of POI and the social events located together? So yeah, based on the lift measure, we find 29 significant association rule among POI and social events. And here is our result. And the left one is is a visualization of this graph of this table, and the ways of arrow represent the support value, and the color represents the confidence value. So take the second one as an example, which means if this place contains financial POI, financial related POI, party related POI, and shopping related POI, they have more chance to host art related social events. And the lift value means the probability to having art related social events in this place is 300% than usual, than a place do not have this POI data. So yeah, so basically this is our result. So next one, I want to talk about the limitation of this model, because there are two limitations for the model. The first one is called oversampling, because in our data set, the number of POI is much greater than the number of social events data. So if we use a data mining approach, the finding would be, how to say, more close to the majority, but overlook the minority, which is our social events data. And the second one is called double counting, because our transaction is based on random points. The random points could be picked at the same or close place, a very close place. So some of the POI data or the social events data may be double counting. So that's a two problem in our model for now. So what's the solution? What I could think about is use the non-transaction based association rule mining, like the distance-based rule mining, but it still require you to predefine the co-location. So we're still working on it. So for the field work, we try to for the first part, we try to interrogate the POI data into building to see the association between building to the social events. Because sometimes there is a large shopping mall, they may contains multi types of POI data, but may only part of it contributes to a social events happen there. So we want to mitigate the effects of that, and we want to make a comparison between the place and between the finding from the place data from the POI, single POI analyze. So this is one aspect we want to do. The second aspect is we keep collecting the data from 2020 to now. So we have the social events data before COVID, and during COVID and after COVID. So we could do the analysis to see how the pandemic changed our social behavior, because some type of social events are gone. And there are a lot of online events right now, according to our data set. So we could see how this pandemic changed our social behavior permanently. So yeah, that's all for my presentation.
Right on.
So,
Thank you. Any question? Yes.
Thank you. Very interesting work. Have you done any work, and if not, then how might you do work to measure the strength of the relationships between the people?
strength
The strength of the relationships between people.
We haven't gone that far yet. Right now, we just want to investigate how the people interact, how the strong relationship between human and the place. We do not go that far to analyze a relationship between among people, but we would definitely go that way. So
How might you do that? Like,
how might
use your expertise.
because in our data set, because we collect the data from a website called Meetup, they also provide the participants information. So we may measure the strengths of among people based on the how many times they appear, the people appear together.
Yeah.
Yeah, basically based on that way. Yeah,
Thank you.
yes, please.
Yeah, I think it's a really great research to understanding people's behavior on the city level. I was also very interested in one of your argument that your research would oversample some of the majorities, but kind of underestimate those minorities. So as our conference is relevant to the ethics of jazz science, I was wondering how you think about this oversampling and underestimate sampling, and how we can better adjust this issue in the future.
Why do we call it oversampling? Because we generated a transaction based on the random points and build buffer about that. Because the number of POI is much greater than the number of social events. So based on the buffer, where a lot of buffer only contains POI, do not contain any social events. So because our analyze, if you go there, you will see our measures is based on probability, right? So how to say this? Because we have transaction only contains POI. This kind of transaction dilute, make the probability. Yeah, become, how to say, dilute the probability of transaction having social events. That's why we may overlook the association to the. But you said how to solve it. Actually, yeah, I did not figure it out. That's why I said this is a limitation of this model. Yeah.
I'm glad you mentioned the limitation, because I remember when I was a PhD, I didn't realize it's a limitation, but I think that's something we can definitely improve in the future. I also think about the underestimated issue relevant to people who might, I mean, as you mentioned, the undersampling is if there are not enough data for making a statistical significant argument that could be underestimated as well. For example, people from a minority group, right? Their behavior also needs to be understood to better serve them.
Thank you.
May I jump in and follow up on that? So with this oversampling, I think it's reflected in your modeling results. Can you go to the table there? I think it's reflected with the support, which is the percentage
See that,
of places, right? That those are really small, like a 1% or 2%.
right?
So only 1 or 2% of the data contains social
Yeah,
networks.
you are right.
Okay, great. And I thought that's an excellent question, talking about minority and so forth. In my understanding, you didn't touch that. There's no demographic information about the participants. Yeah, okay, maybe that's for future work. That's an excellent point. Thank you.
Yes, please.
Do we still have 1 more minute?
Yes.
Okay,
Yes.
yeah, 1 more question. Yes, go ahead.
This, I think this is the slide, you mentioned the fun fact. Men who buy beer also buy diapers or more likely, oh, yeah. I was just curious about that. I said men who buy beer are more likely to buy diapers.
Right. Yeah, that's a funny finding. Yeah.
Does it also go the other way? Men who
No,
buy
no,
diapers
no,
are more likely
no.
to buy diapers.
This is not a symmetric relation. Yeah, it's go one direction.
Interesting.
You can test it the other way around.
Yeah, we
right?
could test it.
And make that as part of X.
Yeah, right.
Any final questions, if any?
Oh.
If not, well, let's move to our final presentation.